we still have to talk about constants. It's not the most exciting subject, but it's definitely something that you'll run into. So let's just dive in. So before I do that, let's just have a quick look at some of the types. I made a little demo program here where I've made a variable of a number of different types. There's loads of types in C++. I'm going to name the most important ones. So there's an integer, a character, a Boolean, a double, a float, a long, an unsigned integer, and a long. Now I've declared all of these. Most of them you've already seen once. This is just an integer, a character, a Boolean. Boolean logic is all about true and false, 1 and 0. We'll go into that. A double and a float, they both hold numbers that have a floating point. So not whole numbers, but numbers with a decimal point. Now the difference between a double and a float is that a double has more precision and a float is faster. Now the differences are subtle, but if you are making an application where you have to have millions of calculations done on a floating point and the precision is not that important, you're better off using a float. But if you need to do a very precise calculation that needs a lot of precision, you have to have a double, but at the cost of not being so fast. Then there's the long, which is basically just an integer. I could have typed long int here, which would have been the same. A long integer is just an integer, but it reserves more space. Now, this differs per computer and per compiler and per operating system. That's why I made this program. I'm going to show how many bytes the compiler reserves for each of these types. And a long will just reserve more memory for an integer than a regular integer. Then there's also an unsigned integer. If I declare an integer variable, I can just as well store in it a negative number or a positive number. It doesn't matter, because one of the bits, or a few of the bits even, are used to indicate the sign of the value. If I use an unsigned value, that means that it's always positive, and that can be essential in some cases. Now, in C++11, a new type was added, which is a long. That doesn't mean that all across the board that has a specific meaning. The only agreement was that this is at least as long as a regular long. So what it means in this case, we'll see. I've made a little list of outputs here where I basically print to the screen the size of each of these variables. So I've declared a variable of each type, and I call the function sizeOf, which is a basic C++ library function, and it will tell me how many bytes the compiler will reserve for this variable. Right? Don't worry about how this looks. This is just a regular way of sending output to the screen in C++. So let's have a look. Press F5. So in here we see it. An integer is 4 bytes long, a character is 1 byte long, a Boolean is 1 byte long, which is funny because a Boolean can actually just be 1 bit long. A double, which makes sense, it's 8 bytes long. A float is 4 bytes long, so a double has double the precision of a float, and double the memory. A long is also 4 bytes long. The unsigned is 4, and a long is 8 bytes long. So this is how it works on my system and using my compiler. So if this is really critical to your application, then it is good to know what the sizes are that your compiler reserves. Now let's actually have a look at constants then. So you saw me assign a 5 to the integer variable here. And 5 is exactly what I mean by a constant. Anything that is on the right side of an assign is basically called an R value. R for right hand side. And this can be an expression. And this can be a very complicated expression. In this case, it's a very simple expression that yields 5. If I typed 5 times 3 here, you know that the result would be 15. It's not a plus. This would be 8. But this thing on the right side is a constant. Now for integer, that's, quite clear. But this is now in the decimal system. In C++, you can do some other things as well. For instance, I can use an octal number. Any number that starts with a 0 and has digits after it that vary from 0 to 7 is an octal number. I haven't talked about octal numbers or hexadecimal numbers or binary, all of that. There are different numbering systems that are often used in assembly, but sometimes also in C++ programs. We'll normally use decimal, but in some cases it's easier to use a different numbering system. Talking about hexadecimal, if I typed this, a 0 and an X, then it would mean a hexadecimal number. And a hexadecimal number can have the numbers 0 to 9, but also the letters A, B, C, D, E, and F. And they mean something in the hexadecimal system. So a value like this is a valid hexadecimal number. It would still mean the same thing as in decimal, but it's written down as a hexadecimal. If I assign a long, like 1, 2, 3, I can add an L to the end to indicate that that is a long. It can also be a small letter L. For float, it's the same thing. 12.5 F means a float. It would mean the same here, but it's always good to tell the compiler all the information that you have, so that if you made a mistake and typed something like this, the compiler might not give an error. But if I typed this, then the compiler would at least have a chance to see, hey, this must be a float, and this is an integer type. So that is just catching errors before they happen. There's one more notation that we can use that we often see, is that it's a binary notation. So if I wanted to assign a binary value to the integer I could start with 0b and then type bits out. So 1, 2, 3, 4, 5, 6, 7, 8 would be 8 bits of this value. Now let's just see what kind of output that would give. So if I wanted to do that, I'd say value of I, and I'd give it the I and an end line. I'm expecting that to be 15. So if I press F5, and you can see that the value of I is 15. So that's worked. Now let's just have a quick look, because this is a nice learning experience as well. If I have an integer and I initialize it with a value of 12.5, and that is a float, it's a number with a decimal point, I'm expecting this to be ignored because I is an integer. So if I press F5 and look at the value of I now, and lo and behold, it is 12 and not 12 and a half. So what if I added an F here? Would that change anything? Because now the compiler knows even better that it's a float. See, even the editor knows it. So I press F5 and I get no error. And I still get 12. So that hasn't really helped me at all. So what I'm doing here is that I'm asking the compiler to convert this 12.5 float value into an integer. That is kind of narrowing it, you know, putting like 10 pounds of potatoes in a 5-pound bag. It's a narrowing conversion from a float to an integer. And the compiler doesn't give me an error, so that's weird. Now, if I initialized this variable, not in the way that we've done it, but in this way, now this might seem a little bit confusing because the curly brackets were also used in the functions, but now we're using it in a very specific place to initialize a variable. If I did it like this, and I pressed F5, see, now the compiler says a conversion from float to int requires a narrowing conversion. So that's exactly what is happening, right? So this was added to C++ to keep us from making mistakes. So if you're initializing variables, it's recommended to always do it in this way if you want to catch yourself making errors. Okay, so let's have a look at character constants next. If I have a character here and I wanted to initialize it with a character value, I would use a single quote, then, for instance, press A, and then close it again. So this is a character constant. A character constant is different from a string because a string has double quotes, and we'll get into strings later, but there's a difference between C-style strings and C++ style strings. That's all very interesting. But a character constant is what we're talking about now, and a character constant has single quotes. So if I initialized C with this, and I printed C out to the screen, I would get what I expect. I get an A. Now, what actually happens is that this A is transformed into its ASCII value. And the ASCII value, the ASCII table assigns numbers to letters, and it's a standard. So anything that supports ASCII should know that A is 65. I wonder what happens if I assigned the same A to I, and then also printed I to the screen. So what I expect now to happen is to be printed 65 here and an A here. Let's have a look. Yes, that works. So the integer comes out as the ASCII value of this character, and the character comes out as the character that belongs to this ASCII value. So that's funny. So this is actually a character, but there's also some other characters that we can use. For instance, we can use the new line character. The new line character will return the cursor to the next line and at the start. Actually, it's a combination of a carriage return, like an old typewriter, a carriage return and a new line. Let's just both assign them this thing and see what happens. So now you can see that we get an extra bunch of new lines. First of all, we get 10, so apparently the ASCII value of the new line is 10. But let's do it this way. If I printed a text here instead of the I, said first line, then I printed the new line character, and then I'd say second line. And then instead of this end line, I would say the character again. I'm going to remove that one. Now it's giving me a little squiggle here, and that's because I forgot those. So I press F5 now. You can see I get the first line, then a new line, the second line, and another new line. So I can use this character constant for that. There are a bunch more, so let's just see. There's also the tab. I'm gonna forget about this I one because it's just confusing. So now I'm expecting the first line and the second line to be printed on the same line. And there we go, first line, second line on the same line. And I'll bet I can string a couple of tabs together as well. There's also a vertical tab, which is this. Let's have a look at what the effect there is. Well, the console doesn't really do anything specific with it. It just prints a little question mark. So it doesn't know what to do with that. But there's a backspace. Let's see what the backspace does. Well, it's printed first line, then the backspace, and then second line, and then the backspace. So it's eaten off the E of the line word in both cases, which is kind of what I expected, yeah. I can also print a backspace. If I want to print a backspace, weirdly enough, I have to type 2 backspaces. And we'll see that this backspace is also called the escape character. So the escape character says that whatever function the next character has is going to be ignored. So normally I wouldn't be able to print this character, but by adding the escape character in front of it, I should be able to print a backspace character. So now I have 2 backspace characters. Also, what if I wanted to print a single quote character? I couldn't just type this because I'd have 3 single quote characters and the compiler can't know that I want to print this and this is the end of the string. What if I wanted to print 2 single quote characters? This is totally confusing. What I could do is escape one of them. So now these outer 2 single quote characters or apostrophes, they delimit the character that I want to print, and I escape this one so that I can just print that. It's a 5, and now I've got a little single quote character. There is a function that we haven't talked about for the single quote. Imagine that I had an integer with a bunch of zeros. To make this more readable to the human eye, I can add single quotes to the number so that we can actually have a look at what my salary is. What does it say? Oh, it's too large for an integer to hold. So I probably should have put this in a long. No, still too long. That's all right. So we can add the single quote character to an integer to make it more readable for ourselves. But let's go back to character constant because that's what we were talking about. Of course, the same goes for a double quote. I can print a double quote that way. And I can use octal numbers. This is an octal number. If I do this, let's see what happens. It doesn't really mean anything, but 10. Yep, that's the new line. So I can also write it like that. And if I wanted to do the same thing for hexadecimal, oh, not that. I can do this. and that would assign hexadecimal A, which is 10 as well, resulting in the same new line. So the next thing that we'll have a look at is the Boolean one. The Boolean constants are basically either false, and I'll make another one. I'll just do BF and another Boolean, be true and true. So Boolean logic, again, is all about determining whether something is false or true, which seems simple enough, but it can get really, really tricky, as we'll see in the future. But the entire digital and binary world revolves around Boolean logic, so it's very, very important. With values like these, I can actually test if something is true or false, and then take action one way or the other, right? So if a user typed M in the menu, then we go this way, and if the user pressed fire, then we do that, otherwise we do something else. So these two, they aren't strings, they aren't numbers, they are actually Boolean constants that you can use as is. What is also important to know is that any number that equals 0 is considered to be the same as false. And that means that any number that is not 0 is considered to be true. Right? So if I want to do a logical test on an integer and it was 0, then that would mean the same as false. If it was not 0, then it would be true. But if we're really working with Booleans, we can just use these Boolean constants, false and true. We'll be seeing these two a lot in the future. And again, when we come to floats and doubles, we can add an F to the end to make it float, but we can also add an E, which is the exponential scientific notation. This, I've never used it, but I'm sure that if you're using C++ in a scientific environment, you'll be sure to run into numbers like these, and you can just use the E as you're used to. You can also use things like this, like a float with a decimal point and then F. You don't even have to provide the decimals after it. You can just type that. So you've seen me use this, which is actually a string constant. But this doesn't have the string type. As you can see at the top here, I've included the string library. Right, so that means that in my code I can now use string s equals this is my name or something. So this is now converted into a string type. But if I just typed it like this, and this is a C string. Now C used to store strings like this, just the bunch of characters, and in memory it would add a little 0 at the end, so that we'd know that that was the end. So this is called a C-style string. This is actually a string type. So if I type this, and this, and I have to, let's keep this the same, 10. See, this is my name, this is my name. There's a couple of things that we can do. Of course, we can also add the constants in like this. So I'm expecting this is my name to be cut in half, as we can see there. We can make it a tab or whatever. That works as well. If I have to type a really, really long string and I want to cut it in half in my code, I can do this. Now this looks a bit weird, but if this string went on and on all the way off the screen, maybe we can simulate that. You know, it's really long and I'm thinking, oh my god, it's going to go off the screen. I don't want that. I can just add a backslash and the compiler will understand that this will go on to the next line. If I press F5, it'll be just the same string. Now it has added the spaces that I added here. So if I did it like that, see, then it has the name there. Add one space, remove this tab, and then it'll probably look a little bit better like that. So I can cut the strings in half. And also something that is important to know is that a string like this is actually considered to be a single string. So white spaces in between strings, like so, they are ignored and they are basically the same as A, B, C, D, E, F, H, G, F, whatever I've typed here. This may be important if you want to format your code for readability. This can be handy in cases. Now, the last thing that you may have seen here below that I want to talk about is these two, is the const and the const expression or const expr keywords. Now, these things are important to us if we're building code. If I use the const keyword to declare and initialize a variable in this case, I make a promise not to change this variable. And it's basically a promise to myself. If I changed CI after this, if I made it 5 times 8, for instance, you would see that there's a little thing here that says expression must be a modifiable value. So this one, this L value in this case, because it lives on the left side of this assign, it's const, and I'm trying to change it. And the compiler says, nope, you can't do that. In this case, the editor does it. If I compile it, it also says expression must be a modifiable value. You cannot assign a variable, or you cannot assign to a variable that is const. So that's exactly what that is for. It's meant to protect me from making mistakes of overriding a variable that I said this should be a const, right? So, and we will see this again many, many times. It'll be a staple when we write functions with parameters that we don't want to change. Now, this was added later to say that the expression that is declared here must be able to be calculated by the compiler. So 5 times 7 is no problem. The compiler can work that out. But if I said 5 times CI, that works. Why? Because CI is const. I promised CI would be constant, so this results in a constant in a constant value. If I made I 3 and I said, well, I want to do 5 times I being a variable, it will already say, look, buddy, an expression must have a constant value. The value of variable I declared at line 6 cannot be used as a constant. And that's exactly what the const expression is for. So this is a really clever system to catch yourself out. Again, you know, it's all meant to prevent your own mistakes. And I almost fell for my own trick because this is a constant, and I kind of didn't see that happening. But it works. This is not okay. So use these as soon as you think, hey, this value shouldn't change. You can really help yourself finding bugs. So I've spilled everything that I have to spill about constants. I'm sure we can talk about this for hours, but I think it's long enough. So thanks for watching, and I'll see you in the next one. Bye-bye.